So hello everyone. Today I want to present you a tool called Argo Rollouts. Basically, the purpose of Argo Rollouts is to make easily Canary and blue-green deployments without using some service mesh like Istio, without installing any sidecar proxy containers. My idea of today's presentation is to create a Canary deployment using NGINX Ingress. I want to show you also how we can make automatically failover if something goes wrong, just to roll back to some previous version. But first, let's start with the architecture of Argo Rollouts and what are the different kind of resources which we use in Kubernetes to make it work. Basically, we have a Argo Rollout manager, which is installed into the Kubernetes cluster. Argo Rollout is creating some custom resource definitions, which we will use. Later, I will show you how they look like and how we can use them. But first, we have a rollout custom resource definition, which is very similar to the default deployment manifest in Kubernetes. We have a service, we have an ingress. In this case, we will use NGINX, as I mentioned. We also have another custom resource definition called analysis template, which the purpose is to analyze the newly deployment, the new version of the service we want to deploy, and to check if it is working correctly or not. Should it roll back to the previous version or not? And this is basically done by getting metrics from Prometheus or some other monitoring tools which we can use. The installation of Argo Rollouts is very simple. 2 lines of code, that's it. As an addition, we can install a plugin to our kubectl command. In my case, because I'm on macOS, I did it with brew command, but of course you have another options. And yeah, this is an example of, because I already mentioned, I will use NGINX. This is just an example of how we can use NGINX, but I will go in more details now. So first, what we have or what we need to make Argo Rollouts working. In our Kubernetes cluster, it's nice to have Grafana because Argo Rollouts are providing us some default dashboards which we can directly use without the need to make some custom ones. We have or we need a Prometheus stack if we want, only if we want to make automatically rollbacks. If we are completely sure that the new code will work fine, we don't need it. But now we will get metrics from Prometheus to check if the requests to the new version of service are working as we expect, basically. And of course, we need an ingress controller to make the ingress. As deployment files, I'm using Ingress, which will basically forward the traffic to our ITGX stable version. We need 2 services. The first one, the both services are pointing as a selector. They use the same application. And this is the first tricky part. When we create the ingress, Argo Rollouts automatically creates second ingress. This one, which we will create, will point to the stable version of the service. And the second one, which will be automatically created, will point to the Canary version, the second service. Next, we have the custom resource definition rollout, which, as I said, is basically the same as deployment in Kubernetes. The difference is in this strategy here. and revision history limit. All of the rest is just a deployment, simple deployment. What this lines here means, first, in Argo rollouts, we need to define what kind of deployments we want. In our case, we will use Canary deployment. We need to specify both services, Canary and stable, with their names, which we created above. We need to define what kind of ingress we will use, in this case, NGINX. And here we need to define the stable ingress resource. In our case, it's this one here on top. Next, we need to define the strategy of the deployment. What we have here is to set weight. This is basically the percent of traffic we want to send to the Canary deployment. So first we will send 10% of the traffic for 30 seconds, then 25% for another 30 seconds, and last 50% for another 30 seconds. This one here means how much deployments or history versions we want to keep. This is important if we want to roll back to really old version, let's say more than 2 or 3. That's why I said here 5. We will be able to roll back to 5 versions in the past. So now I will deploy this these resources into my Kubernetes cluster. And yeah, this is the pod created here. Let me show you the ingress. This is basically the ingress which was defined in our configuration file, and this is the automatically created ingress by Argo Rollouts. As we can see, it's pointing to service Canary. This is done automatically, so no need to think about that. Now, one more thing, we can use or Argo Rollouts give us a dashboard. I will use kubectl Argo Rollouts dashboard. How it looks like, here is it. So in the dashboard, we can see our rollouts deployed to the Kubernetes cluster. When we click on it, we are able to see the different steps defined in our rollout manifest. And as we can see now, everything was fine with the deployment. And because also this was the first revision, it's automatically forward all of the traffic to this service. But now I will change the image tag, so we will have another version. Before that, let me show you how it looks like. This is an application or image provided by Argo Rollouts, where I'm using it because it's really simple to and easy to show you how it looks like, and I am able to generate some errors here. So I'll be able to show you how it will automatically roll back to previous version if something goes wrong with the new one. I will change the tag from blue to, let's say, green. And what will happen now? Okay, here is the new version. If I open the dashboard, we can see that 10% are already forwarded to the new green version. And now we need to wait a couple of more seconds to go to 50%. One step is missing here in the steps, and this is the step to forward all the traffic to the new version. I will show you how we can do that in the next deployment. If you want to, let's say, forward only 20%, and you want to be completely sure that everything works before deploy the new version fully, I mean, all the traffic to go to the new version, we need to click on Promote button. We have here in the dashboard 2 buttons, Promote and Promote Full. Promote is when it go to the latest step, we can promote, or when it go to some of the steps, we can promote to the next step, but we can also promote to full, which means, yeah, deploy everything. And here we will see that the blue image will go out and all the traffic will go to the green image. Now, if I change the image to another version, let's say yellow, even if I generate some errors, it will not roll back to the previous version. And to make it able to roll out automatically, we need to define another customer source definition. And this is analysis template. The analysis template is able to check or to get information from different sources, like Prometheus, like they call it web, but it's basically curl, and checking the response. Is it 200? Is it not? Is there an issue with the service backend? And yeah, basically the analysis template is the resource which we use to make Argo rollouts, to be able to check if the new version is working and to make automatically rollbacks. In my case, I'm using Prometheus. What I found as an issue when I was generating this resource was that I had to define the whole service path. Here, it was not able just to use Prometheus operated .default, for example. I had to define everything. And you can see in my Prometheus, if I execute the same query, it gives me that an answer that everything's fine because 100% of the requests are fine. Now I will change the image to yellow. Yeah, let me show you about the differences between version 2 and version 1. Compare selected. Yeah, the image version. This analysis template here should be added into the strategy, in this case, Canary. We are able to define more than one analysis template. For example, we can take metrics from Prometheus and to use web and to use another sources at the same time, and we can just add them here into the list of templates. Also, we are able to integrate some of these analyses after some specific step. For example, we can use Prometheus to check the metrics after the first step and use some other tool to check the metrics after second step of deployment. Yeah, now I will just use it as generic. So let's deploy version 2. The deployment has started. As you probably saw in steps, we have one more step which will deploy the new version completely. If everything's fine, it will basically do it. And what I want to do now is to generate some errors. The new version is yellow, I think. So I will generate some errors. Let's see what will happen. I can show you one more thing here. Dashboard. Yeah, we have this basic, let's say, dashboard where we can see each revision of our deployment. Do we receive some errors? Is it the stable version or Canary version, and so on? So let's see what's happening now. Okay, it was deployed. Probably I had to generate the errors more quickly. Yeah. Okay, I generate them after the time passed. I will generate a new one. Let's use blue and deploy version 3. The time for the deployment is more now. It's 60 seconds, so we will have time to see the errors and so on. Open blue and generate some errors. Here is it. Here is the boot deployment. The first error come. In analysis template, I defined power limits of 3, which means if I have more than 3 errors, it will automatically roll back to the previous version. Let's see what will happen. Okay, now we have 3. And on the 4th error, we basically received this message here, rollout aborted, because yeah, basically it didn't pass the analysis template, the query defined here from Prometheus. If I open Prometheus, we will see that it drops from 100% to 60 something, 65, and then it drops to 0 because I basically generate a lot of errors. And the blue deployment has been automatically rolled back to the yellow one because of the generated errors. We can use Argo Rollouts with different ingress controllers. For example, we can use it with traffic. We can use it with Google Cloud Ingress using a plugin. I can show you an example, I think, here. Just in the traffic rollout, we need to use plugins and define the plugin for Google Cloud. And also, we are able to get metrics, as I said, from different providers. In my case, I use Prometheus to make queries, but we can use web, where we basically creating some curl, and it checks the response. By the way, I used one here below, just to put it or to use it after step 2 here. So when I run the last deployment, it basically used the Prometheus for all steps and web only after second step of deployment. Yeah, I used Grafana service just to be sure that everything will work fine, but of course you can use some custom endpoints to check if your service is working or not. The Grafana dashboard, no need to go in much details here, but yeah, they basically provide us a lot of useful information, I think, for our deployments. And basically that's it. This is how we can use Canary deployments only with NGINX and Prometheus without using any service mentioned, as I said, to install sidecar proxy containers and so on, which could lead to more load in our clusters, of course. So do you have any questions?
The only way I've seen this is with Istio, which already has, you know, the built-in capabilities for routing traffic based on percentage of requests and so on.
Yep.
Have you drilled down on how this actually worked with NGINX? Is it adding some custom NGINX config in the Ingress, or?
One of the requirements for using NGINX was to, in my case, let me show you. Yeah, just into the chart, I had to enable these metrics here, which are, you know, provided by NGINX by default. So no custom configurations. Once we enable the metrics, and yeah, another thing, I had to install Prometheus stack because in the stack we have custom resource definitions used in the query I used to get real metrics for my service. There is no any other custom configurations. It's just the NGINX as it is, and we basically create the Ingress resource, which is basically how we usually do. I mean, as you see, nothing special, and it do not create any additional resources to make it to work.
Nice.
It's working really nice. It doesn't lead to some more load in our Kubernetes cluster. And this was my idea when I start working with it, just to make the Canary deployments available without, you know, using things like Istio, which, yeah, we receive a lot of possibilities with it, but sometimes it's just too heavy, let's say, or overloaded.
Yep. So maybe the logic happens in the Kubernetes service then. I would guess, if it's decoupled from the Ingress controller.
Yeah, this is true, but also we have this rollout manifest, which we basically do not have deployment, and the Argo Rollouts operator, the manager, it's basically monitoring all of these resources and is able to switch or to control the traffic to the different ingresses, which are basically, you know, connected to the different services, so different versions of application. That's it. Really, really simple. So yeah, do you have some more questions?
No, it was very interesting. Thank you very much.
Thanks everyone, and have a nice day.